So for the chemical characteristics, we have both inorganic and organic constituents. So we start with the inorganic constituents. So we'll go one by one. So first of all, we'll talk about phosphate, inorganic phosphate. So first of all, the experiment, what are we doing, what is the observation, and hence the inference that we have, let's say like in this case phosphate, and then what is the normal range, which condition increased, which condition decreased, and same for all the other constituents as well. So phosphate, what are we doing? Urine, we are taking urine, 5 ml, we are adding concentrated nitric acid. Concentrated nitric acid. Five drops. And we are taking ammonium molybdate. So 5 ml urine plus 5 drops of concentrated nitric acid plus ammonium molybdate. We have to warm and observe. Warm and observe. So what is the observation which we expect? It will be a canary yellow precipitate. You should write the full word, precipitate, canary yellow precipitate. This is due to the formation of the compound ammonium phosphomolybdate, ammonium phosphomolybdate. And hence the inference is that phosphate is present in the sample. So talking of the normal range of excretion, means how much phosphate is excreted in the urine per day. So it's approximately 1 gram per day. And if they ask for a range, then you might give it as 0.7 to 1.5 gram per day. This is the normal excretion of the phosphate in the urine. And now which conditions it is increased, which conditions it is decreased. This is a very, very frequently asked thing in the Viva, the exam Viva. So increased in, first of all, diet rich in phosphorus. Diet rich in phosphorus. P stands for phosphorus. And also increased in hyperparathyroidism. This is 1, this is 2. Decreased in which conditions? It's very simple. Since you have said hyper here, obviously decreased in hypoparathyroidism. And rickets. So, urinary phosphate excretion is increased in phosphate-rich diet and hyperparathyroidism. And urinary phosphate excretion is decreased in hypoparathyroidism and rickets. Don't get confused. Now, talking of the second constituent, that is calcium. First, we start with the procedure. Take urine, 5 ml, then we add 1% acetic acid, 1% acetic acid, 5 drops, then we take 2% potassium oxalate. We take 2% potassium oxalate. This is also 5 ml. So 5 ml, 5 drops, 5 ml. Students tend to get confused about the amounts. This is from a standard practical textbook. So what is the observation? Trace white precipitate. You should write the full word in the exam, precipitate. Trace white precipitate. So why we have this precipitate? It is due to the formation of calcium oxalate. Calcium oxalate. And hence the inference is calcium present in normal urine. Now, normal excretion. So how much of calcium is excreted in the urine daily? So the amount is actually very less. It is 100 to 300 milligrams per day. Milligrams per day. Not grams, milligrams. And as the amount is so less, that is why the precipitate is trace. Trace. If it was more amount, then it would not be trace, it would be a proper white. But as we have very less excretion, so we have a very trace precipitate. Now finally coming to the last part. So in which conditions do we get increased calcium excretion in the urine? 1. Hyperthyroidism. Hyperthyroidism. 2. The favorite of many students. They keep on telling this for many answers. Multiple myeloma. So, 2 conditions where calcium is increased in the urine excretion, hyperthyroidism and multiple myeloma. And name 1 condition where the calcium excretion is decreased. Rickets. So, calcium excretion is decreased in rickets. Now talking of inorganic constituent number 3, which is ammonia. We start with the experimental procedure. So we take urine, 5 ml. To that we add 2% sodium carbonate. We take 1 to 2 ml. Now we boil this. We boil and we hold a moistened red litmus paper. Hold moistened red litmus paper at the mouth of the test tube. Mouth of the test tube. So what is the observation? This red litmus paper which you are putting, the red paper will turn blue. Red litmus turns blue. So why is this happening? Because when you are doing this boiling, so then the ammonia is being liberated. So once the ammonia is liberated, as the ammonia itself is alkaline, so this ammonia will turn the red litmus to blue. Now inference. So obviously ammonia is present in normal urine. Now talking about the viva parts which are commonly asked. What is the normal excretion and which conditions increased, which conditions decreased. So normal excretion is approximately 0.5 to 0.8 grams per day. This is the normal urinary excretion of ammonia, 0.5 to 0.8 grams per day. And where does this come from? This comes from glutamine and the other amino acids in the kidney. Glutamine and the other amino acids in the kidney. So now finally, which conditions increased, which conditions decreased? Increased in acid forming foods, acidosis, UTI, urinary tract infection. So in these conditions you will find more amount of the ammonia being excreted in the urine. And which conditions do you find ammonia excretion in the urine decreased? Simple. Here if you have acidosis, obviously you will have alkalosis here. Obviously. And nephritis.